Hi guys, my name is Jeferson Costa. I'm a chemical process engineer with expertise in plant design, and today I will teach you how to use Aspen HYSYS to size a control valve. Before I start, let me invite you to know my other social media like YouTube, Telegram, LinkedIn, and I have a fan page in Facebook also. And more than that, in my website, jeffersoncosta.com, you'll find my blog where you can have much more information about chemical process engineering and plant design. And if you think that you should use rating model of Aspen HYSYS, I have bad news for you because we don't use that for control valve sizing. It can be helpful if you want to do a dynamic simulation for your process, but we don't use that to decide or to calculate my CV because I have better and more reliable tools to do that. So I will not get in details about this table in Aspen HYSYS, but we need for sure, as chemical process engineers, we need information for Aspen HYSYS to sizing our valve. So I will disclose this tab and I will show you now what we really do in real life. Depending on the company that you are working on, if it's big or if it's medium or if it's small, the responsibility for sizing and selecting a control valve may change. In some places, it is responsibility of the chemical process engineers. In other ones, it is responsibility of the instrumentation engineer. But in any case, you will need at least to inform the process data for the person that is responsible for sizing the control valve. And the template that you use to do that may vary from company to company, but I like this one because here you have not only information about process data, but also other information important to the design of the control valve, and some of those information is responsibility of the process engineer also. But before going in more details in the control valve datasheet, I will show you how to size the control valve. So let's start filling the control valve process datasheet based on Aspen HYSYS information. So we have here we need to identify the fluid. In this case is a mix of gases and it is in the state of gas. And flow, in this case we have here a node tree, and it means that flow rate is based on normal cubic meter, and as I have told you, we need 2115 normal cubic meters per hour, and according to the contract it is the normal flow or the average flow. So in this case I update here, and I need to know what is the minimum and the maximum desired flow. It will depend on your process. If you are delivering gas to a customer at the battery limit, usually there is a range of flow that you need to supply the customer, but if you don't have that, you can consider for instance, depending on the case, 25% for more and 25% for less. If you are sizing this control valve for equipment, this flow can be associated with the equipment turn down, and turn down is the minimum operation condition that the equipment or the system can run safely. In this case, I can consider 120 as maximum required flow, and according to the contract, I need to supply at the minimum of 800 normal cubic meters. The inlet pressure, I will consider 39.5 because I need to consider the pipe pressure drop, but it is not a big issue, and I will consider that at constant for now. And the outlet pressure is 4 bar G, and I will consider that as a constant. but you may observe that it fluctuates during the operation, but if it is close to these values, it's not a big deal. And now I will inform the temperature, that is 50 degrees Celsius. To have the density, I need to go to the property of the stream. It is 41.48. We can add also the viscosity. Viscosity is 0.013 and molecular weight is 23.45. Cp-CV is 1.388 and finally the Z factor is 0.861. Just take attention that all of this information here, the properties information, is based on the inlet stream in the valve and not at the outlet of the valve. If we change that, the results in the calculation will be different. As we had filled our process information in the control valve datasheet, now we can go to the sizing of the control valve. And we do that based on the manufacturer or supplier of our control valve. There are many of them in the market. I bring to you at least 3 where you can download for free the software to practice at your home. And I like to use Samsung because it is very simple and intuitive to handle. But we have also Fisher from Emerson, and we have here also Neoprof from Metso. And what changes from a supplier from another is the interface and information that they have inside the software, because the software is integrated with their catalog. And although the CV calculation would be the same, the final valve selection depends on the supplier catalog. It is very similar to pipe sizing. You don't choose a pipe with 5.35 inches inside diameter, even if it is the best inside diameter that you need to have the right velocity of flow and to have the better pressure drop, because suppliers don't do or do not fabricate that kind of pipe. You need to choose a standardized pipe, and it is very similar not only for control valves but also for PSVs. Let me inform you that I let available for my members in process some of the stuffs I have in my Dropbox, and I will let the link for downloading Samsung software there after this class. I cannot guarantee that when you are seeing this video it will be up to date, but for practicing it is enough and it is free for use. So to download Samsung software from my Dropbox, you just need to be an in-process member in my Telegram channel. Based on that, let's go to the Samsung valve sizing program interface. And the main goal that we have here is pre-selecting our control valve in order that we can help other disciplines with information for detailing design or basic engineering, or eventually you can be doing a conceptual design and you need to do quotation. So if you have pre-selected your control valve, it will help you to get costs and so on. Moreover, we can verify if the control valve is able to work in the range of operations that we need, or if we will need to consider more advanced control strategy like split range and so on. First of all, let's set the condition for valve sizing, and I will add a tag that is FV401, and it is in the gas phase. It's not vapor. It is vapor when we have a saturated gas stream. So we have gas, and there is information here. Okay, and the medium, if you are sizing a control valve for a pure substance, eventually you have in the data bank of the software. For instance, I have been working with hydrogen a lot, and with oxygen also, and nitrogen. So in this case, the software already have the information that it's needed to do the calculation, but in our case it is a mixed gas, so we will need to inform the information that we want to the software, and we can pre-select the type of body of the valve, and so there are multiple joists here, but as we have pressure drop too high, the best type in this case is globe. But for instance, if you were designing a valve for a water system with low pressure drop, you could consider a butterfly valve depending on the size. And I have seen in a polypropylene plant a lot of control valves with ball valve type, and there are others here also. So I will choose globe type, and the actuator is pneumatic. Another information that I will preset here is the ECV, because I want to calculate the CV, not KV. And the pipe size I want to know in inches because it's easier for my understanding, and the pipe class also in class. And I will also change pipe information. In this case, there are a difference between valve and pipe. This size here in the valve tab is the size of the valve, and in the pipe tab is the size of the pipe, because you will see very often that the size of the control valve is lower than the size of the pipe. It's very common. So I want to inform the pipe size as in inches. So let's go to process data, and here I want to inform the flow in normal cubic meters, okay, but the pressure, inlet pressure, I want to inform in bar G. So you just need to do a double click here, and the pressure downstream I want bar G also, and temperature in Celsius. And now I will fill the information that we have in the control valve datasheet. See that I just transferred the information from the datasheet for the software, and now I need to add the medium data also. And before filling this, I will change this information for those ones that I have, and I want the density, and I want the viscosity and centipoise. And now I will do the same that I did to the process data, that is transfer the information that I have in the datasheet for the software. See that I just transferred the information from the datasheet for the software, and now I need to add the medium data also. And before filling this, I will change this information for those ones that I have, and I want the density, and I want the viscosity and centipoise. And now I will do the same that I did to the process data, that is transfer the information that I have in the datasheet for the software. And here, before I proceed, I would like to alert you that gamma means the CP/CV. Okay, so it is the same information, 1.388. So we have here, Z is the compressor factor, and we have eta, in fact, is viscosity, and we have the density in kilograms per cubic meter. So I informed all information that I had and was available in the control valve datasheet, and now I can inform data related to the pipe if I already calculate that, and it is very common. Before going to the process datasheet, we already have calculated the pipe sizing. It is one of the first step that we do in a plan design. And if you are not sure how to do that, I also have a video about that, and you may see a link to that video now. And in this case, I will not fill the pipe information, and now just what we need is click on calculate valve. There is an alert related to sound pressure level, and because of safety issues, personal safety issues, and that's why you need to use hearing protection. But the normal condition for noise, it's around 85 decibels. So I have 91 only in the worst case. So because of that, I will not change anything. And I will change another information here. I don't want KV, I want CV. So what we got here was the CV calculated, and you may know that for CV calculation there are a lot of ways to do that, and for control valves that is not a trivial issue. There are a lot of constants and square roots and etc. to be developed, but in fact it's what I want to show you, that we have CV calculated for 3 conditions, but the software choose a CV5 because the supplier don't have the CV to supply you. For instance, I can change the CV here in the software, and below 5 I have 3, and 3 do not attend to the process condition. So I need, for this supplier, I need a valve with CV5 to my process. And the valve size in this case is 2 inches, and based on pressure, it is calculated also the class rating, it's 300, and it already shows for me the type of valve opening. I will not get in details now, but there are other kinds of valve opening, like linear and on-off valve that I mentioned to you. It's the on-off valve is not controlled, okay? And we can evaluate the valve performance in verifying the graphs. So this is the valve performance. So in the minimum flow, the valve will be around 60% open, and at the maximum value, the valve will be around 90%. It's desired that in normal flow, the valve operates around 60 to 70% open. So now I will change the CV of this valve, and we will verify what is the new performance of the valve. I will change for 7.5, okay, And now I will ask the program to recalculate the valve, and I will re-enter. He wants to know if I would like to confirm the value I enter. I will say yes. And now let's see the new performance. So see that with the new valve, we changed the characteristic of the valve opening, and I can also change the opening to verify if it is better for me. And now I ask the software to recalculate again, and now we have another kind of graph. So what we will do is verifying what is the best conditions for your valve, and I will do a last change here. I will return for 5, and let's see, okay, and recalculate. And now I believe that this valve better fits what I want, because we are far away from the 100%. You don't want to control a process at 100% open valve, because if you are doing that, you are not controlling anything. And normal flow, we are closer to 50 and 70 range, and at the lower flow I have around 25% open, and so this condition is okay for me. So instead of choosing equal percentage valve, I will choose opening conditions of linear, and CV5 is the best fit for me, and the valve size is 2 inches. And print these results. You just go to print preview, and you have a Samsung datasheet here. If you are going to do the quotation with Samsung, no problem. You can print that in PDF and send to them to do the quotation. But if you want to do quotation with other suppliers, it is better to send the control valve process datasheet. In any case, I will print this one, and I will let this available in my in-process channel. You can download that to practice the control valve sizing alone. And finally, we will return to the control valve process datasheet to finish that, and I will talking about some consideration that you need to have in the process datasheet. And after that, I'm pretty sure that you are able to do your own calculation alone. We are back to the control valve datasheet, and as I told you, the information that you need to inform for the person that needs to size the control valve is those ones filled in salmon, okay? But there are other information that I think it is important to you know, because with that you will do a better job and show to your boss or for someone that is interviewing you that you understanding about control valve sizing. And I really believe that less than 5% of people that left the chemical engineering courses knows what I'm teaching to you right now. In fact, many process engineers with 1 or 2 years of experience don't know what you are learning right now. So pay attention. You need to add a tag or identification for your control valve. So you will do that based on the service of the valve. In this case, I want to control flow, so because of that I use FV, and you need to inform how many valves do you want, and there are processes that we need to have a standby valve, and if that is the case, you, instead of buying just one valve, you would buy two, and eventually the tag, instead of FV 401 would be FV 401A, and also FV 400B. So this means that we have two valves and one is a spare of another. Add also to your control valve datasheet the piping instrumentation diagram number and the sheet that valve is, to make it easier to identify where it is and to add the information that the piping engineer needs to know during the detailing design. The service is good to add also because it makes it easier to identify the importance of the valve. In this case, I want to control flow to the customer, and because of that, I identified as flow control valve to the customer. And I already calculated the line size, and you can observe that the line size in this case is the same of the pre-selected control valve. And here I have the pipe size at the inlet of the control valve and also the outlet and the schedule of the pipe. And you need to inform area classification. It is related if we have flammable source in the area where the control valve will be installed, and as we are working with flammable gas, it is expected that we can have flammable source there. So because of that, we have a classification here. We pre-select the type of valve that we want. During your practice, you can change the valve type and see if the software responds to you with a valve suitable for the process conditions. And in this case, we have a 2 inches control valve with 200 pounds class. Another interesting information that should know is how fluid goes through the valve. So in this case, it goes from bottom to the up, and because of that, the flow tends to open the valve instead of closing the valve. And the tidiness class is related to the allowable leaking rate in the valve seat. So higher is the number of tidiness class, more tight the valve is. And the control characteristic, I will change that also to linear, because as we have seen, it is better for us. And just to let you know, this one, note 1, is to inform that it is supply selection, and I will only verify that when I receive the quotation, but I will not decide what the supplier must offer to us. Another very important information for valve sizing is the fail position, because it is related to safety, and as valve needs a source of energy to open and to modulate, or sometimes to close, we need to inform if that energy is shut down, what position the valve should go. The most common is fail closed and fail open. It means that if we lose air to the valve, for instance, the valve will close, and if we lose air to the valve, it will open. And to do that decision, you need to know what is the purpose of your valve. So in this case, I'm controlling the flow to the customer. I know if my valve fails and it gets opened, I will have too much gas coming from the truck, and because of that the heating exchanging system will not able to heat the gas. We can have liquid at the vessel separated and eventually send the liquid to the customer. So instead of having a valve with fail position open, it's safer to have a fail position closed. If something gets wrong, the valve will close instead of open. Another important information is the air supply pressure, because different actuators must require different air supply. So it is interesting to inform that for the manufacturer. And if your control valve will be installed in the field without no protection for environment and for rain and for dust, it's important to inform the IP ingress protection, and there is a table for that, and I will not get in details, but in my blog I have a post about that there. You can take a look at my blog, and many things that I'm discussing with you here, I have already posted an article in my blog. And finally, we reach the operating conditions. You already know how important it is. And here I will add the calculate CV. It's not mandatory because the supplier will calculate that also, but it is interesting to have to compare with the manufacturer information. So to finish our control valve datasheet, I will show you that in this case I have a sheet for notes. So if you have important notes, you can add here. And we have a table of units, and we need to have the cover, and in the cover you will identify the documentation number, and very important, you need to add a date. So I will use the date of today. It is April 2nd, 2020, and the execution. And it is very important to have at least a person to check what you have done. In this case, I will consider that this control valve datasheet is for approval. And with that, my friend, you finish your valve sizing, and I'm pretty sure that you have a lot of information here, and eventually you need to watch this class more than once. And if you want to have this spreadsheet for you, this editable version, you just need to like this, share this, and when we reach 100 likes for this video, I will add this document in my Dropbox for in-process members. So this is the way I like to teach chemical process engineering. And if you have any question about this video, you can do a question in the comments, or you can send me a message in LinkedIn, no problem. My name is Jeferson Costa, the chemical process engineer in plant design.